All right, so get this. Someone actually requested a deep dive into compression testing.
Compression testing.
Yeah, like how much pressure something can take before it cracks. But
Oh.
the twist is we're not talking steel or concrete.
Hmm.
This is about beryllium oxide.
Beryllium
Yeah,
oxide.
so that's where things get interesting.
Yeah, beryllium oxide, or BeO for short, it
Hmm.
has some incredible properties.
Oh, yeah?
Yeah, it's super strong, withstands crazy high temperatures, and transfers heat really efficiently.
Wow, so like what kind of applications?
Well, that's why it's so valuable in the energy sector, especially for things like nuclear reactors and advanced electronics.
Nuclear reactors.
Hmm.
Wow, okay, so that makes sense. It's got to be tough.
Yeah, does that.
There's a catch, though, right? It's not exactly something you want to, mess around with at home.
Oh, yeah, exactly. BeO is highly toxic.
Oh,
You can't just treat it like any other material.
right.
There's a risk of contamination. And get this, it can actually damage the testing equipment itself. Yeah, imagine that the material you're testing could break the machine that's designed to test it.
So like needing a super strong safe to hold something that could melt the safe itself.
Exactly, it's a real challenge.
Yeah. So this energy company that needs to know how much pressure BeO can handle, like vital information for its applications.
Mhm.
But how do you even begin to test something that could potentially harm both the people and the testing equipment?
Well, that's the challenge a company called Infinita Lab took on.
Okay.
And they knew they couldn't just jump in head first. This wasn't your typical compression test.
Right.
They started by doing a deep dive of their own researching BeO, understanding its risks, and then doing a thorough risk assessment.
To figure out the safest way.
Yeah, the safest and most accurate way to do this.
So they took the time to really understand what they were dealing with.
Absolutely, because safety's on the line.
Yeah, makes sense.
And then they went a step further.
Oh, really?
They actually designed a custom testing setup.
Oh.
Yeah, they engineered a special containment chamber for the compression testing.
So like to contain the material itself.
Exactly. They used a combination of inert gas purging and a negative pressure system.
Hmm. I don't really know what that means.
Basically, they created an environment where any loose BeO particles would be contained and prevented from escaping and causing harm.
So it's like building a hazmat suit for a robot.
Precisely, and they knew they couldn't do it alone.
Uh-huh.
They teamed up with a specialized lab that handles hazardous materials.
Oh, okay.
It's not just about the equipment, it's about having the right expertise in safety protocols and procedures.
Makes sense.
Yeah.
So did all this planning and precaution actually work?
It did. Infinita Lab successfully completed the tests.
Okay.
They got precise, reliable data on BeO strength, exactly what the energy company needed.
Great. And so, like, are they done?
No, and get this, the project was such a success that the company keeps coming back.
Wow, really?
Yeah, Infinita Lab has completed multiple BeO compression tests since then, with even more planned for the future.
So they've become like the go-to place for this kind of specialized testing.
Pretty much.
Which makes you wonder, if working with BeO is so tricky, why bother?
Yeah, that's a good question.
Why not just find a safer material?
When we first started working with BeO, it was a bit intimidating. We had to be extremely careful, almost like working with, a volatile explosive.
Wow.
But there's also a certain thrill in pushing the boundaries of what's possible and BeO's unique properties.
Like, what makes it so unique?
Its strength, thermal conductivity, and ability to withstand those high temperatures make it irreplaceable in certain applications.
So it's like a powerful but unruly horse. You need the right skills and equipment to harness its power.
That's a great analogy.
Yeah.
And it brings up an interesting question. If BeO is so valuable but so challenging to work with, what other innovations are being developed to harness its potential more safely and efficiently? What does the future of BeO in the energy sector look like? Something to think about.
Absolutely. Thanks for listening, everybody. We'll see you next time for another deep dive.
Bye.